Sentinels of the cosmos, unveiling the mysteries of galactic halos. Imagine our galaxy, the Milky Way, as a majestic cosmic city, ablaze with the light of billions of stars. Now picture this city enveloped by a vast and mysterious halo, a realm extending far beyond the visible disk of stars and gas. This is the galactic halo, an expansive region that holds clues to the formation, evolution, and ultimate fate of galaxies like our own. These halos are the invisible giants of the cosmos, their gravitational influence shaping the destinies of the galaxies they encompass. For decades, astronomers have been piecing together the enigmatic nature of galactic halos, using a combination of observations, theoretical models, and cutting-edge simulations. What they have uncovered is a realm of astounding complexity and beauty, where dark matter reigns supreme and the echoes of ancient cosmic events linger for billions of years. By studying these celestial guardians, we gain a deeper understanding of the fundamental processes that have shaped the universe we inhabit. In this exploration of galactic halos, we will journey into the heart of these cosmic mysteries. We will delve into the invisible realm of dark matter, the elusive substance that dominates these halos and holds the key to their gravitational sway. We will trace the origins of halos back to the early universe, witnessing their assembly through cosmic collisions and the accretion of smaller galaxies. And we will uncover the secrets hidden within their ethereal depths, from the ghostly trails of stellar streams to the ancient relics of globular clusters. Join us as we embark on this captivating adventure through the cosmos, unraveling the mysteries of galactic halos and their profound implications for our understanding of the universe.
The elusive grip of dark matter shaping galaxies from the shadows. One of the most intriguing aspects of galactic halos is their intimate connection to dark matter, a mysterious substance that makes up the vast majority of the matter in the universe. Unlike ordinary matter, which interacts with light, dark matter remains invisible to our telescopes, revealing its presence only through its gravitational effects. It is within galactic halos where the gravitational influence of dark matter truly takes center stage, shaping the structure and evolution of galaxies on grand scales. Astronomers first began to suspect the existence of dark matter in the 1930s, when they observed that galaxies were rotating much faster than they should be, based on the visible matter alone. These anomalous rotation curves, as they are known, implied the presence of a massive, invisible component providing the extra gravity needed to hold these rapidly spinning galaxies together. This invisible component, it turned out, resided primarily in the vast halos surrounding galaxies, its gravitational influence extending far beyond the visible disk of stars and gas. While we cannot directly observe dark matter, its gravitational effects provide compelling evidence for its existence and its crucial role in shaping the universe as we know it. In the case of galactic halos, dark matter acts as the invisible scaffolding upon which galaxies are built, its gravitational pull drawing in and concentrating the ordinary matter that will eventually give rise to stars and planets. Without dark matter, galaxies would likely not have formed at all, or at least not in the magnificent structures we observe today. The precise nature of dark matter remains one of the most profound mysteries in modern astrophysics. Scientists are actively pursuing various theories and experiments to unlock its secrets, hoping to shed light on this elusive substance that makes up the majority of the matter in our universe. By studying galactic halos, where dark matter's influence is most apparent, we hope to gain a better understanding of this enigmatic component of the cosmos and its role in shaping the universe we inhabit.
Echoes of cosmic collisions, stellar streams, and the assembly of halos. Galactic halos are not merely static envelopes of dark matter, they are dynamic and ever-evolving structures, shaped by the cosmic events that have unfolded over billions of years. One of the key processes that contributes to the growth and complexity of halos is the accretion of smaller galaxies, the remnants of which are often left scattered throughout the halo in the form of stellar streams. These streams, like ghostly rivers of stars flowing through the halo, provide valuable insights into the hierarchical assembly of galaxies and the history of interactions experienced by their host halos. Stellar streams are formed when a smaller galaxy ventures too close to a larger one and is torn apart by the immense tidal forces at play. As the disrupted galaxy is stretched and pulled apart, its stars are strewn out along its orbital path, creating a long, thin stream of stars that orbits within the halo of the larger galaxy. These streams can persist for billions of years, serving as long-lasting records of past galactic encounters. By studying the properties of stellar streams, such as their stellar populations, chemical compositions, and orbital characteristics, astronomers can glean valuable information about the nature of the disrupted galaxies, the timing of these cosmic collisions, and the distribution of mass within the host halo. These streams serve as cosmic fossils, preserving evidence of events that transpired long ago, providing us with a glimpse into the dynamic history of our galaxy and its surrounding halo. The study of stellar streams is a rapidly evolving field, fueled by the increasing capabilities of telescopes and surveys. As we continue to map out the stellar halos of galaxies in greater detail, we can expect to uncover a wealth of new stellar streams, each with its own unique story to tell about the formation and evolution of galaxies and their surrounding halos.